In the last lesson, we learned about logarithmic functions and logarithms as inverses of exponents. In this particular lesson, we're going to actually talk about the properties of logarithms. And since we basically know that they are a conversion of an exponent, knowing the properties of exponents comes in real handy here. So a lot of the rules or the properties that you remember from exponent properties are going to be very similar to the logarithm properties. Now, a couple things that you got to remember from a previous lesson also are the inverse rules that you see here in this given box. And I want you to remember that if we had log base a of a, if you'll recall that equal to 1. Now you can see that we're raising it to an x power and it just equals to x, and we'll discuss that in a little bit more detail here in a second. And same thing with the exponential property. If we took a raised to the exponent of a log, we would end up with the x value the same way, and we'll kind of connect these two together through the course of this lesson a little bit. All right, so if we look down here, we have a really good example of basically how we can come up with these log properties based off of our understanding of exponential properties. If you look here, we've taken these three logs, log base 2 8, log base 2 4, log base 2 32, and we've converted them to exponential form. So you can see that we have 2 to the third times 2 squared equals 2 to the fifth. Now, you know that we equal 2 to the fifth based off of simple exponential properties because the bases are the same, so we would add the exponents. Now, let's take a little further look at this. If you look here at 3 plus 2 equals to 5, the log that represents the 3 and the log that represents the 2 and the 5 could be rewritten or substituted in for those exponential values, since we know log base 2 8 equals to 3. And since we substitute those in, we have this log statement here. Well, you can see by breaking up the 32 into 8 times 4, we've created this statement where the addition of these two logs actually converts to a multiplication into a singular log. So this is going to be one of our log properties where we can condense two logs into a singular log, and they stem from the exponent properties and what we know about the values of logs. And so that's a very good example of how exponential properties and logarithmic properties will connect to each other. Now, we can do that for a number of other rules, and if you look in this concept box here to start, we actually can show you there's three rules that we're going to focus on: the product property, the quotient property, and the power property. Now, here, what I want you to focus on is that the multiplication can lead to addition when you expand. Okay, and what we mean by expand the log is we're taking one log and we're breaking it up into multiple log statements. Now, if we wanted to condense multiple log statements into a singular log statement, we could actually go the opposite direction. We could go from addition back to multiplication. The same thing happens with the quotient property. What you'll see here is that the division leads to subtraction, and of course if we were condensing, we could go back the other way as well. And then finally we have the power property, where if we have a log base and then that logarithm is being raised to a power, that power can then become a multiple. So the power can become a multiple of the entire log, and you can see that we're going to take that and put that in front of the log, and of course it can go vice versa. And that goes back to our inverse property where we showed you log base a of a raised to the x power is simply equal to x. And if you think about how that works, if we had log base a raised to the x power, that x becomes a power multiplied times log base a of a, and we know log a of a is equal to 1, so 1 times x is just simply x. And that's where that inverse property comes from. Now, in the following concept box, we actually show you how the exponent rules and the logarithmic rules kind of match each other. And so you see the product rule where we're multiplying with the same base, so we can break that up and we can add the exponents. The logarithm rule is similar to that. Multiplication becomes addition. And so we're kind of using a lot of the same properties for both exponents and logarithms. Okay, so that's a good quick introduction to logarithmic properties. In the next video, we'll work the sample problems. So if you want to go ahead and take a look at the examples and work the sample problems, come back in the next video to see the solutions. Okay, we'll start with example number 1. And if you notice here in the directions, it says to expand the given log. So that we're going to use our log properties here to take our single log statement and break it up into as many log parts as we can. And so we'll eventually get down to the point where we can't expand anymore based off of our log properties. So if you look at here at example number 1, the first thing that we decide to do is we break the division up and make it into subtraction. And we do that first before we try to start breaking up the multiplication, and then lastly we use the power property on x to the third. So there's a definite order of operations that kind of takes place here in order to kind of unwind a log statement. And so that just kind of comes with a little bit of experience. There's no hard and fast rule. You kind of have to just see what you're dealing with at the given time. And so there'll be plenty of practice problems for you on Math Excel to get a good feel for this. So if we look at sample problem number 1, and we want to expand this log. First off, we want to break up the multiplication into addition first. Notice that the power of 6 only goes with the x. It doesn't go with the 2 because we don't have parentheses around the 2x. And so we definitely want to take care of that first. Now, keep in mind here, we start with log base 5, so every log here is going to also be log base 5. And we will get into some more challenging problems later on where we might have different base logs that we want to use the properties for, and we'll tackle those a little bit later. Now, we've split up the multiplication into addition, but I'm still not finished because I have an exponent here, and I can put that 6 as a multiple of the log. Now, you can write it how I have it here if it makes you feel more comfortable and recognize that 6 is being multiplied to the log. You can use parentheses, and that's appropriate as well. But that is our expanded version of that log statement. Okay, so let's take a look at the next one. You can see here in example 2, it just simply says to simplify. Now that's different than expand. Simplify really kind of means the same thing as condense. So you will also see the word condense as a possible direction as well. So what we're doing here is we're taking multiple log statements given to us and we're trying to compress them down into one singular log statement. Now if you also notice something about example 2, there is no base, or the base in this case is 10 because it's understood. And so we can continue to use the log properties the same as we did before without having to write the base 10. Now again, a little bit of order of operations comes into play here. You definitely want to get everything condensed singularly before you start to put together the addition and the subtraction. So, and you can get a feel for that as well as you do more and more of these problems. So in sample problem number 2, we'll start by making 2 go back to an exponent. So log base 3, 7 raised to the second power. And same thing with the 5, log base 3, x raised to the 5th power. Now subtraction leads us to division. Keep in mind, when we condense here, we are absolutely going to one single statement. The log statement does not go on both top and bottom of the division. It's just one single log and division. Now, what would be appropriate here is, since we have 7 squared, that's a numerical expression, we want to simplify that according to the directions, but x to the 5th obviously cannot, and so that would be our simplified or condensed log. Okay, so these are some good examples using the properties of logarithms. Clearly in class and in Math Excel we'll be giving you some more challenging opportunities to work with these properties.